This video is going to talk about characteristics of functions, graphs. So while we're looking at graphs, we want to think about inequalities and how those work with our graph. We're looking at something like this. F of x is greater than equal 0, less than 0, greater than 0, something like that. So on our graph, anything above the x-axis here, the y values are greater than 0 because they're positive. And anything that is below the x-axis is going to be y is less than 0 because that's our negative values down here for a given x. And then when we have on the x-axis, then we have y is equal to 0. Our inequality over here is asking us to find greater than or equal to 0. So that means that we want to be on, because that would be equal to, and above the x-axis. So what does that show us? Well, on the x-axis, I have negative 2, and I also have positive 2. But above the x-axis, I have this part of my graph. I want to know what x's satisfy this. So the x is an element of, and this is just 1 point, so we say negative 2 union, and then we start at 2, but anything larger would also satisfy our inequality. So bracket 2 to infinity. All right. So when we talk about increasing and decreasing, we're really talking about as I go from left to right. Does my graph go, do my y's keep getting bigger and bigger, or do my y's keep getting smaller and smaller? So here they want us to look at these first 2 points. Okay, and if I look at those 2 points, I want to compare their y's because that'll tell me whether I've increased as my x's got larger or decreased. So when I look at y2 compared to y1, which is really what this is saying, the output of x2 compared to the output of x1. This one, x2, the output looks like it's 1, and the output of x1 looks like it's negative 3. Then we would say that f of x2 is greater than f of x1. Write the interval of increasing, constant, and or decreasing of the graph. And if we look at our graph from left to right, we start here and we go up. These y's are getting bigger and bigger, so we're increasing. And we look here and we also see that we're increasing at the very end of the graph. So we can say that x is an element from negative infinity up to, and we'll call that negative 2. And then it starts back up, and we'll call that maybe 1/2, and that will go on to infinity. A constant. There is no place where this graph is the same for several x values, so this one's not applicable. And then we look at where it's decreasing. Obviously, that's what's in between my 2 increasings. It starts at this point here, and it ends at this point here. So we're going to say that x is an element between negative 2 and 1/2. Now notice that I've always used parentheses because it's increasing at that end point and decreasing all at the same time, so we just make it a parenthesis. And then we also want to look at the end behaviors, and this is just the way that we'll talk about this more later. But right now we're just going to look at it and notice that on the left-hand side of this graph, if I look at it, we could say that it is going down on the left, and we could say that it's going up on the right. So we could call that down up kind of in behavior. Characteristic we're going to talk about is the maximums and minimum values. The y coordinates, that's important to know. These are going to be y coordinates, not x coordinates. Most everything else we talked about, we've been saying x is an element of. But in the y coordinates here, we would say that the peaks would be the maximum values. So here, we would say that the max would be y equal, and it looks like it would be 1. And if we did the valleys are called the minimums. So these points down here. Okay? And min, and y is going to be equal to, and it looks like it's at negative 3. Then it tells us all peaks and values can be evaluated as local. All of them are going to be local or relative maximums or minimums. It depends on how you see them written and the first time you learn them probably. I learned them as local. So we'll say L max and L min for local and max and min. And then there's this global. Global or absolute is the largest or smallest y value over the entire domain. We're not going to include the infinities, but we look at this graph and we have lowest point on this graph. This function does not go any lower than -3. So we would say that we have I learned it as an absolute min, because that's the lowest point, at y equal -3. Okay, if I had this graph right here, but then it's got a max and it's got a min, but it does not have an absolute max and min because it goes to infinity on both ends. It's down, up. And if you have a down, up situation, you're never going to have an absolute max or min. So we have one more characteristic to talk about, and that is the zeros. So the zeros of a function is where the graph touches the x-axis, because this is when the y value would be 0. Thus, they're called zeros. So if we go back and look at the graph that we were just looking at, we have a point right here, and we have one here and here. So there are 4 zeros here. We have 4 zeros, and they are all x's equal to, because we already know what y is. That's why it's called a 0. And x would be equal to -2. And that looks like it would be -1/2, and then +1/2, and then +2.